10 questions were done. We are starting with question number 11. Before I start the question number 11, I would request you to pause the video for 1-2 seconds. Go through the problem for at least 3 times so that you can understand कि आपको क्या पूछा है and क्या दिया है. ठीक है, चलिए. Suppose that number of moles of gas present at 27 degrees Celsius in flask of volume V and pressure P is N1. Suppose के 27 डिग्री सेल्सियस के ऊपर वॉल्यूम ऑफ द फ्लास्क V है, प्रेशर P है और मोल्स ऑफ द गैस जो है वो N1 है. Assuming the ideal behavior and applying the ideal gas equation, so what from ideal gas equation we can write? P dot V is equal to N1 into R into 300. This is your equation 1. Now let us suppose that N2 is equal to moles of gas at temperature T is equal to 477 degrees Celsius is equal to 750 Kelvin. So what we can write from ideal gas equation? So again from ideal gas equation, what we can write? P dot V is equal to N2 dot R multiplied by 750, equation number 2. So if we divide equation 1 divide by equation 2, what you will be getting? So N2 is equal to 300 divided by 750 multiplied by N1. So this is 0.4 multiplied by N1. So what does that mean? That moles of N2 are 40% of N1. That means the volume of the gas expelled. So volume of gas expelled, just a second, the volume of the gas expelled out is equal to 1 minus 0.4, that is 0.6. If you want to convert this into percentage, this will be equal to 60%. Done. The next is question number 12. Calculate the temperature of 4 moles of a gas. So what we can write about answer? N is 4 moles. The pressure of the gas is 3.32 bar. The volume of the gas is 5 decimeters cube. The value of R is 0.083 bar decimeter cube Kelvin inverse mole inverse. So we know that PV is equal to nRT. So what will be the temperature? Temperature will be P dot V upon N dot R. The pressure of the gas is 3.32. Volume of the gas is 5. The moles of the gas is 4. And the value of R is 0.083. So what will be the value of temperature? This is 50 Kelvin. Moving on to the next problem, 5.13. Calculate total number of electrons present in 1.4 grams of dinitrogen gas. So let us find out the number of moles. Number of moles of dinitrogen gas is equal to 1.4, that is weight upon molecular weight. This is equal to 0.05. The number of molecules in 1.4 gram dinitrogen gas is equal to 0.05 multiplied by 6.023 into 10 to the power 23. Why? क्योंकि अगर एक मोल गैस होती, एक मोल, तो 6.023 into 10 to the power 23 मॉलिक्यूल्स होते ना. यहाँ पर तो हमारे पास 0.05 मोल है. Number of molecules 0.05 multiplied by 6.023 into 10 to the power 23 molecules. So this is equal to 3.011 10 to the power 22 molecules. This much amount of N2 molecules are present in 1.4 grams of dinitrogen or 0.05 moles of dinitrogen. Now, one molecule of dinitrogen is equal to how many electrons? 14 electrons. Dinitrogen get 14 electrons. So 3.011 into 10 to the power 22 molecules of dinitrogen will contain how much? The answer is 14 multiplied by 3.011 10 to the power 12. So the answer will be 4.2154 10 to the power 23 electrons. This much amount of electrons will be present. How much time it would take to distribute one Avogadro number of wheat grains if 10 to the power 10 grains, this is 10 to the power 10 grains, are distributed in 1 second. If you want to arrange 10 to the power 10 grains, you will require 1 second. So how many you are supposed to arrange? The Avogadro number, that is 6.023 into 10 to the power 23 grains is equal to how much seconds? The answer is 6.022, yeah, 23, no matters, divided by 10 to the power 10. So it is 6.022 into 10 to the power 13 seconds. Is it done? Okay. Now you can convert this into many other units also, but I am keeping this in the second only. Calculate the total pressure of mixture of 8 grams of dioxygen and 4 grams of dihydrogen confined in the vessel of 1 decimeter cube. Temperature is 27, R is 0.083 bar decimeter cube per Kelvin per mole. So what we are doing is we are calculating the partial pressure of dihydrogen as well as dioxygen. So let us say कि partial pressure of oxygen gas, the partial pressure of oxygen gas P is equal to nRT upon V. So what is the value of N? The value of N is 8 upon 32, weight upon molecular weight. What is the volume? The volume of the gas is 1 decimeter cube. The temperature T is 300 Kelvin. Temperature is 300 Kelvin. And the value of R will be obviously 0.083. It's because atmosphere is there. Okay. So, what will be the partial pressure? Partial pressure of dioxygen will be 8 divided by 32. The value of R will be 0.083. Temperature is 300 and the volume of the gas is 1. The answer is 6.225 bar. Okay. Now, the partial pressure of हाइड्रोजन गैस का पार्शियल प्रेशर कैलकुलेट कर लेते हैं इन द सेम वे. PH2 is equal to nRT upon V. The weight of dihydrogen is 4, molecular weight is 1, because I am directly putting N is equal to weight upon molecular weight. 4 upon 2 I am directly putting, that is 2. The ARCA value is 0.083, the temperature is 300 Kelvin, and the volume of the gas is 1 decimeter cube. So this is 49.8 bar. 49.8 bar. So what will be the total pressure? The total pressure will be equal to 6.225 bar plus 49.8 bar. The answer will be equal to 56.025 bar. Okay. Moving on to the next problem. Question number 16. I will request you to pause the video for 1 to 3 seconds and go through the problem for at least thrice, and then we will see the solution. Okay. The volume of the balloon, since the balloon is spherical, volume of the balloon will be given by 4 upon 3 pi r cube. Remember, we are supposed to find the value of mass of displaced air and mass of the balloon. These two values we are supposed to have. If we have these two values, we can have the data of payload. The volume of the balloon is 4 upon 3 pi r cube. The radius of balloon r is 10 meters. The radius has been given as 10 meters. So what will be the volume? The volume will be 4 upon 3. The pi ka value is 3.14. R is 10 cube. So what will be the value? 4186.7 meter cube. Now what is the mass of displaced air? Let us calculate the mass of displaced air. So for mass of displaced air, what we are going to do is we will be multiplying the volume with simple density. Why? Because volume multiplied by density is mass. Let us keep with units only. This is volume. Now let us take the density. The density is 1.2 kilogram per meter cube. The meter cube can cancel. This is 5024.04 kilograms. Now moles of helium gas. So one thing we have got, that is mass of displaced air we have got. Now it's turn to have the mass of balloon. Mass of balloon will comprise of two things. The first is mass of balloon itself, which is nearly equal to 100 kilograms, and the second is the mass of helium. Now how to calculate the mass of helium? First we will be calculating the moles of helium by the ideal gas equation, PV upon RT, because moles we are supposed to find out, so it is PV upon RT. So pressure is 1.66 bar. Volume of the balloon is 4180.6 into, mind it, this time we will be putting 10 to the power 3 over here. Okay. Now it is 0. Centimeter cube. 0. Arca value is 0.083. In temperature is 300. So what will be the value? 279.11 into 10 to the power 3 moles. Everything was as same, but the one minute difference was this 10 to the power 3. Since the unit was meter cube, we were supposed to convert in the appropriate volumes of what you can say, meter cubes to appropriate conversion volumes as 10 to the power 3 meter cubes में से. So mass of the filled balloon will be, mass of filled balloon will be equal to sorry, first we are supposed to calculate the mass of helium that we haven't calculated. So the mass of helium present, the mass of helium present is equal to the weight multiplied by the molecular mass. So this will be equal to 1116.44 kilograms. Done. The mass of the helium, what we are doing is we are multiplying the moles with the molecular mass. So you will be getting the mass of helium present. Done. Okay. So now you have got the mass of helium gas. Add this with the mass of balloon. So what will be getting? You will be getting the mass of filled balloon. The mass of filled balloon. How much is the weight of balloon? That is 100. What is the weight of helium? This one we already have calculated. So 1216.44 kilogram is the mass of balloon. Now from the formula what you can write, the payload is mass of displaced air minus the mass of balloon. Mass of displaced air, you are knowing that it is equal to 5024.04. Already have calculated. Have a look. Minus mass of balloon, just we have calculated 1216.44. The answer is 3807.6 kilograms. Done. Okay. Moving on to the next problem. Calculate the volume occupied by 8.8 grams of CO2 at 31.1 degrees Celsius and 1 bar pressure. The value of R is given to you as 0.083 bar liter per Kelvin per mole. So from ideal gas equation what we can write? From ideal gas equation, PV is equal to what? nRT. What is N? The N is weight upon molecular weight, 8.8 divided by volume, volume of the gas, or molecular mass of the gas is 44. This much amount of moles. Pressure P is 1 bar. 1 bar. Temperature is 273 plus 31.1. This is 304.1 Kelvin. The volume we are supposed to find out, and the value of R is 0.083 R liter per Kelvin per mole. So you are supposed to put the values in this equation, nRT upon P, that you can do by yourself. The answer you will be getting as 5.05 liters. Moving on to the next problem. 2.9 grams of a gas at 95 degrees Celsius occupies the same volume as 0.184 grams of dinitrogen at 17 degrees Celsius. At the same pressure, what is the molar mass of the gas? Let the molar mass of gas, molar mass of gas is equal to M. What will be the moles of gas? The moles of gas N is equal to the weight of the gas divided by molecular mass. Molecular mass is unknown, so it is M. The what is temperature? Temperature is 273 plus 95, that is 368 Kelvin. So from PV is equal to nRT, what we can write? The V is equal to nRT upon P. So the value of N will be 2.9. The moles of the gas, 2.9 upon M. Pressure of the gas, we are not concerned. Same pressure is there in both the cases, so we are putting P. R, the gases are same. and the temperature is 368. Okay. Now let us calculate for dihydrogen. The moles of dihydrogen is 0.184 divided by 2. This is 0.092. The temperature is 273 plus 17, which is equal to 290 Kelvin. Now the volume of dihydrogen is from this equation. The moles are 0.092. Value of R is R. Temperature is the same. Temperature is 290 Kelvin because it is 17 degrees Celsius, and the pressure is the same in both the cases, P. Now the volume of hydrogen gas and the volume of this gas are same. Okay, this is given in the condition only, so we can compare both of them. Let us compare. Why we can compare? Because it is given that both the gas have same volume. Compare 1 with 2. Let us compare the equation 1 with 2. 2.9 multiplied by R multiplied by 368 upon M into P is equal to 0.092 multiplied by R multiplied by 290. So what will be the molecular mass you will be getting? The molecular mass M you will be getting as 40. The molecular mass M we will be getting as 14 gram per mole. Done. Next, question number 19. A mixture of dihydrogen and dioxygen gas at 1 bar pressure have 20% by weight as dihydrogen, so 80% is the dioxygen. Calculate the partial pressure of dihydrogen. Okay, let us say the total mixture is 100 grams. The total mixture weight is 100 grams. So what will be the mass of hydrogen? The mass of hydrogen is equal to 20 upon 100 multiplied by 100. This is 20 grams. Okay. Number of moles of hydrogen. Number of moles of hydrogen is equal to weight of hydrogen 20 divided by molecular mass, that is 10 moles. In the same way, the mass of hydrogen is equal to 100 minus 20, that is 80 grams, and number of moles of oxygen as 80 divided by 32. Since dioxygen is there, we will write 30 to 80 upon 32, that is 2.5 moles. So the total number of moles of hydrogen and oxygen is equal to 10 plus 2.5, that is 12.5. Total number of moles are 12.5. Now what will be the mole fraction? We are necessary to find out mole fraction because we are going to apply the Dalton's law. The mole fraction of dihydrogen is equal to moles of dihydrogen. Moles of dihydrogen is 0 or 10. Moles of dihydrogen was 10. Moles of dihydrogen we already have calculated as 10 divided by the total moles. Total moles of dihydrogen plus oxygen is 10 plus 2.5, that is 12.5. 4 upon 5, the answer is 0.8. Total pressure of the mixture is 1 bar. Total pressure of the mixture is 1 bar. So the partial pressure of dihydrogen gas will be equal to P total. let us say that this is pH2 P total multiplied by the mole fraction of dihydrogen. P total is 1, mole fraction is 0.8. So what we can say is 0.8 bar. Done. Let us go for the next. What would be the SI units of the quantity? P into V square into T square. I don't understand why this question is asked over here, but still it is given, so we'll be doing. The pressure unit of the pressure is Newton per meter square. The unit of volume is meter cube. The doing square of that is meter cube square. Here it is Kelvin square divided by mole. So the answer would be Newton meter raised to 4 Kelvin square mole inverse. Done. Okay. The next is, in terms of Charles law, why minus 273 Celsius is the lowest possible temperature. This question I am giving in the homework that we already have discussed in Charles law. You can go through the previous videos, we will be finding that. 22. The critical temperature for carbon dioxide and methane are given to you, which has the stronger intermolecular force. तो देखो, higher the critical temperature, TC of the gas, जितना गैस का critical temperature ज्यादा, easier is the liquefaction of gas. Liquefaction of the gas जो है वो easy होता है. CO2 has higher critical temperature TC, so liquefaction is easy. और जितना गैस का liquefaction easy होगा उतना ही intermolecular forces strong होंगे. So intermolecular, क्योंकि intermolecular forces strong होंगे तभी तो easily liquefy होगा ना, तभी तो molecules नजदीक नजदीक आएंगे. अगर intermolecular forces बहुत weak है तो उनको नजदीक लाने में मुश्किल होगी. तो CO2 जिसका TC ज्यादा है उसका liquefaction आसानी से होगा और उसका critical temperature भी ज्यादा होगा और intermolecular forces भी strong होंगे. Explain the physical significance of van der Waals parameters. There are two van der Waals parameters, A and B. The A represents the attraction factor. This represents the attraction factor. This is attraction forces between the molecules. This is attraction forces between molecules. Attraction forces between the molecules. And the B is bigness or effective size of gas molecules. This represents the effective size of gas molecules. ठीक है, तो this is the physical significance of the van der Waals parameters A and B. So by this question I am ending up this session. We will be starting the new chapter from next lectures. Till that time, keep studying. Thank you very much. Have a nice day.